Okay, so all request to put your roll number. Okay, good afternoon. So we'll start our last chapter. So I request all of you just put your roll number in chat box. Okay, so we will start shortly. Okay, so we have completed our first 5 chapters. That is the first section, and in second section we have completed 2 chapters. Okay, so this is our last chapter. That is unit number 6. That is the statistical process control. Okay, so we are going to cover the syllabus. That is the introduction part of the statistical process control. Then we will see control charts for variable and attributes. Okay, so what are the control charts for the variables and attributes? Then interpretation and application of the X, R, P, and C charts. We will see these 4 charts in details, and we will see some applications of these different charts. Then process capabilities. Then we will see acceptance sampling plans, then its types, single and double, then operating characteristics curve, then producer and consumer risk, and some numerical treatment on these different charts and sampling method. Okay, so we will see the syllabus in this last chapter. Okay, so we will cover this chapter in next up to 25th May. Okay, our target is completion of the syllabus is 25th May. Okay, so afterwards we will see some test and review of all the first section and second section. Okay, so we will start our last chapter. That is a statistical process control. Okay, so SPC means what? Okay, so it is a process of monitoring and measuring variability in the performance of the process or a machine through the interpretation of statistical techniques, and it is employed to manage in a process quality. Simply, it is nothing but one of the quality and quality assurance in production and tool for the continuous improvement. So what are the, we have seen some 7 quality control tools like this SPC is nothing but one of the very important tool for continuous improvement in our quality process. So it is defined as the use of the statistical technique to control the process or production method. Okay, SPC tools and procedures can help you monitor process behavior, discover issues in internal systems, and find solution for the production issues. SPC म्हणजे काय थोडक्यात की तुमच्या प्रोसेसमध्ये जे काय स्टॅटिस्टिकल डेटा असेल, जे तुम्हाला फर्दर रिक्वायरमेंटसाठी लागणार असेल, तो डेटा हा कॅल्क्युलेट करून देतो किंवा कंट्रोल करतो. आणि याच्यामध्ये जी काही प्रोसिजर आहे जी सुरू असेल मॅन्युफॅक्चरिंगची असेल किंवा प्रोडक्शनची असेल, तर त्याच्यामध्ये मॉनिटरिंग करण्याचं काम म्हणजे जे काही प्रोसेस चालू आहे त्याचं बिहेवियर, त्याचे कंट्रोलिंग, त्याचं जे काही इश्यू असतील, जे डिफेक्ट असतील हे फाइंड आउट करणे, शोधून देणे आणि डिटेक्ट करणे हे ते एसपीसीचं काम आहे, जे आपल्याला व्हिज्युअली दिसत नाही, इंटरनल इश्यू असतील ते क्लिअर करतात आणि त्याच्यावरती परत सोल्युशन देतात. ते म्हणजे स्टॅटिस्टिकल प्रोसेस control. Okay, okay, statistics means what? Okay, we have heard that is statistical control, process control. In that, what is mean by statistics? So statistics is a branch of the science that deals with the collection, tabulation, interpretation, and presentation of the data. Okay, otherwise present the questionnaires charts. So now you can see it is one of the just method to present all the data regarding that process in various methods. You can go for the pie chart, bar chart, or line chart. That is just a way to different way to present your statistical data in that process. So it is one of the just a branch of the science where we are going to just show our actual process data. So what are the objectives of this SPC? statistical process control. So first objective is collecting the data and drawing meaningful conclusion. Okay, so very important objective of this process, that is a collection of the data of that particular process, and from that processes data you have to show the meaningful conclusion. So that is the first objective. Second, finding root causes of the problems. Whatever problems, defects, errors coming from the internal system, so that things this SPC will be show you main causes of that problems. That is the root of the causes problem. Then controlling of the performance. So because of this SPC, we can control the performance of our process. If our process is going smooth, then there is no problem regarding the performance. But in that system, in that process, if there is a error, defect, any major drawback, so we can with the help of this SPC, we can easily find out that defect, and we can take corrective action, and we can control the performance of the process. Then predicting future tendency. By using this SPC, we can predict or just hypothesis. We can build a small hypothesis regarding this or process in the future tendency of that machine or processes. Understanding and managing variability in a process. So that is another objective regarding this SPC. That is understanding between this process and managing all the variables. That will be a big task regarding this SPC. Preventing defects and to pursue never ending improvements. We have to avoid some defects, errors in the process by using this SPC, and we are trying to give a endless improvement in this process. We are not stopping the improvement of this process. So that is the main objectives of this SPC. Statistical thinking is a philosophy of learning and taken on the following principle, like all work assumes all work in a system and processes and reducing variations of this. We have to just understand the process and try to reduce the variation it implies directly for your success. Okay. And we have to interconnected. So we have to interconnect each other. Okay. So statistical things a theory. So it is to identify where improvement is needed. So SPC is especially we are using for find out the ways to improve. Okay. So improve the any process. That step we can easily find out by using this. It provides a general approach to take tools to use, and by using that SPC method, we suggest which tool we have to use in this process. Okay, so that is a very important task. So what does SPC mean? Actually, what is meant by this statistical process and control? So statistical is just tools are used to make a prediction on performance with a high degree of accuracy. Okay, so statistical already we have seen it is just a science term deals with the we are just presenting some data from our processes. Okay, so it's the degree of accuracy and processes. The processes involves people, machine, material, methods, management, and environment working together to produce an output such as end product. So whatever we have given some objective, given some target to our processes. So that target we have to complete throughout the using this involvement of this all the elements that is called as the processes. Okay, working together. That is an important part. And last one is a control. So control, this is a control system which uses statistical techniques for knowing changes in the processes. So controlling is one of the most important part in any SPC or any method. Here we have to adjust, we have to take corrective action according to that processes. So controlling phase is very important in any processes. It is an effective method in preventing defects and helps continuous quality improvement. So by using the controlling techniques, by using the controlling process, we can effectively prevent the next future defects. You can say like you can just prevent the making the defect manufacturing, and we can continue gives a quality improvement product. Okay, so that is called as a control. So next is control chart. So basically you can see below one graph is there. Okay, x-axis belongs and y-axis belongs to the some values. We have taken some values, and by using that graph we have given some lower control limit and upper control limit. Okay, and mean there is a control limit. So lower control limit, that is x bar minus 3 sigma, and upper control limit, that is x bar plus 3 sigma. Okay, and control limit, that means mean, whatever the mean of that value is there in the table, that will be x bar. Okay, so control chart, it is a graphical representation of the collected information. Whatever we have collected information from that processes we are going to represent it by this using this different control chart. So it is a just a way to represent the information, whatever the collected. Okay, the information may pertain to measured quality characteristics and judgment quality characteristics of the sample. Whatever we have taken the reading as a sampling method, whatever the, suppose we can take the example of the our 100 parts reading. In that 100 we are taking randomly 10 or 15 reading from that sample, and we are going to be checking or measuring that performance. Okay, so it detects the variation in the processing and warn it there is any departure from the specified tolerance limit. If we have taken that 10 or 15 sampling, and in that 10 or 15 sample we got some value higher than the upper limit or lower than the lower control limit, then we have to go for the controlling. By using this chart we can easily understood our process is going within this limit, means upper or lower, then it is okay. But if our process is going to upper than this upper level control limit and lower than the lower control limit, then we have to take some corrective action, and then we have to go for the again our process. So this is a very important work done by this controlling chart. Okay, a statistical tool to study the variation in the process over the time. So it means we are going to continue checking the time to time by this controlling chart, and we can understood, we can easily identify the some defective part through this controlling chart. So a control chart always has a center line for the average, then an upper line for the upper control limit and lower line for the lower control limit, and these lines are determined from historical data. So by using these three lines we can easily sort out our problems, our major statistical data by using this controlling chart. Okay. So what is the purpose of this control chart? Basic question. So purpose of this control chart, that is analyze the past data. Okay, means whatever the data of that particular product, means previous data, which that data we are going to analyze, and depending regarding that data we are going to determine the performance of the processes and measure the control of the process against the standard, and then we are going to consider our making over some standards, and we are going to just making some measurement regarding that our current processes. Okay, so this is the purpose of the control charts. Okay, so control charts for variable and attributes. So we have currently seen just what is meant by control charts and what is the purpose of the control charts, and we have seen some benefits regarding that control chart, how we are going to controlling that the values in between upper limit and lower limit. Okay, so now that controlling chart we have to see for the some variable and attributes. Okay, so now you can see here control charts divides two parts for the variables and attributes, and again variables divided for the two charts, that is a average chart, that means x bar chart, and range chart, that is a R chart. So charts for the variable is divided into two subtypes, that is called as a x bar chart and R chart. Okay, please remember variable charts means X bar and R chart. And attribute charts is again divided into two types, that is called as defective item and defects per unit. Okay, charts for defective items and charts for defects per unit. Okay, remember. Then again, the defective items divide into two types, that is called as P chart and NP chart, means fraction defective, that is a varied sample size, म्हणजे सॅम्पल वेगवेगळ्या प्रकारचे साईजचे असतील त्याच्यामध्ये आपण हे पी चार्ट त्याला म्हणू शकतो, त्याच्यातून आपण ते डिफेक्टिव्ह कॅल्क्युलेट करू शकतो. आणि number of defective, that is a constant sample size, so we are going to taking a constant sample size. Okay, so that called as NP chart. And the defects per unit again divided into two types, that is called as a constant sample size, that is a C chart, and varied sample size, that is a U chart. Okay, so we have seen till now 6 subtype of these variables and attribute charts. Okay, so basically variables which is having two types, X bar and R, and charts for the attributes in that P chart, NP chart, C chart, and U chart. So we will see one by one, but before moving towards, we will see some basic difference between the variable charts and attribute charts. Okay, so in the variable charts, we will see X bar, R, and uh, sigma charts. We can add here one more also, sigma charts we can use in the variable charts also. Okay, and in attribute charts we can find out, we can use NP chart, P chart, C chart, U charts. Okay, second point, in variable charts, so types of the data required. Okay, in variable charts we can require the data, types of the data, variables data, that is a measured values of the characteristics. व्हेरिएबल चार्ट्स मध्ये आपल्याला टाइप ऑफ द डेटा लागतो, त्याच्यामध्ये जो मोजण्यासारखा डेटा आहे तो लागतो. ठीक आहे, आणि इकडे ऍट्रिब्यूट डेटा युजिंग गो गेज अँड नो गेज. हियर वी कॅन गो फॉर द just measuring the attribute data by using the no gauge and go gauge. Okay, in the variable charts, field of the application control of the industrial characteristics. Okay, and here control of the proportion of the defective or number of defects or number of the defects per unit, means that is we are finding the defect by using this different chart in the variable as well as attribute. They are just totally controlling the industrial characteristics in the variable, and defects or number of defects that call as attributes. So what are the advantages of the variable charts and what are the advantages of the attribute charts? So first we will see variable charts. It provides maximum utilization of the information available from the data. So basically variable charts, that means X bar, R, and sigma charts will provide maximum utilization of the information available from the data. जे काही तुम्ही डेटा दिलाय त्यापासून ते मॅक्झिमम तुम्हाला ते माहिती देण्याचं काम करतील. It provides detailed information on the process, average, and variation for control dimension. तर याच्यातून आपल्याला डिटेल मध्ये मिळून जाईल. त्यामधून व्हेरिएबल चार्ट्स as compared to attributes. So see, so are all available from the respective records. याच्यामध्ये डेटा जो तो ऑलरेडी understand by all process seems simple as compared to X bar and R chart. So as compared to variable chart, attribute chart, all information already available, and it is very simple to understand, and it provides overall picture of quality history. So basically attribute chart will be easy for understand, will be easy for drawing, and it will provide all over information regarding that quality history. And what are the disadvantages of this variable and attribute? So variable disadvantages is they are not easily understood unless training is provided. So for the using this variable charts, we have to need some trained person. Okay, so that is the first disadvantages. It can cause confusion between control limits and specification limit. So confusion is more in the variable charts. Okay, to understand the control limits and specification limit, that will be confusing part. It cannot use with no gauge, go gauge type gauge inspection. ह्याच्यामध्ये आपण go gauge, no gauge सारखे inspection use करू शकत नाही. That will be a disadvantages. Here in attribute charts, they do not provide detailed information for the control of the individual characteristics. Okay, so in the variable charts we will get some individual characteristics information, but in attribute we cannot get this, and they do not recognize different degrees of defectiveness, weightage of the defect. In the attribute charts we do not get some different degrees of defectiveness. That will be a great disadvantages in the attribute charts. Okay, so these are the some differences between these two very important variable charts and attribute charts. So summary. Okay, summary definition we will take some. The central tendency is the extent to which all the data values group around the typical out center value. जे काही आपण सगळी डेटा गोळा करतो by using the different charts, so that will be a just central tendency to find out the values. Okay, and the variation is the amount of dispersion or scattering of values. आणि जे काही तुम्हाला व्हॅरिएशन भेटेल त्या व्हॅल्यूचं ते आपण परत कॅल्क्युलेट करणार आहोत. The shape is the pattern of the distribution of the values from the lowest value to the highest value. Then we are going to calculate that a simple graph by using different charts, and we can just find out the shape of that, the pattern of the distribution, where we have get the values from the lowest value to the highest value. Okay, so I will show you. We will see one or two example based on these first two types, and then we will move towards next part, that is a sampling. Okay, so wait for a few minutes. Okay, my screen is visible. Okay, so we'll see control chart calculation of procedure. Okay, how to calculate the this different control chart by using this some different formulas. So we'll see one by one. So first, calculate the overall average x bar and range r for the each subgroup. Okay, so suppose we have taken some samples like x1 to x3, x3, x4, x5. Okay, so that 5 samples we have taken. So we have to find out the average. So simple formula, x bar is equal to the addition of this all the 5, x1, x2, x3, x4, x5 divided by number of the samples, that means a 5. So simply you can get for the average. Okay, and how to calculate the range, r capital is equal to highest value minus lowest value. So we will get the sum of range. So how to calculate the range? So just highest value among these 5 sample and minus lowest value. So you will get range. Okay, second, calculate the grand average x bar
Hello, sir.
Okay, now I am audible.
Yes, sir.
Okay, thank you. Okay, my screen is visible.
Yes, sir.
Okay, so we have to find out the three sigma limits. Okay, so sigma dash is equal to r bar by d2. D2 means we have to take on this all the values from the one of the table. So I will provide the table soon. So d2 for the particular sample size. So suppose we have taken the sample like a 10 sample, 20, 30. So that particular sample batch, we have some sample value that is a d2. That value we can taken from the directly table. Okay, so don't worry for that. We have to take the values, don't worry. So again, sigma into x bar is equal to sigma dash divided by under root n. So this is the standard formula. We can calculate the three sigma limits. One is a upper, one is a lower. Okay, so now 3 sigma bar, that is a upper control limit, that is a x bar is equal to x double bar, that is the average of average, plus 3 sigma x bar. And for lower limit we can calculate, that is a x bar is equal to x average of average minus 3 sigma x bar. So this is the formula, and this formula we can modify with the help of the above formula, that is a x bar is equal to x average of average plus a2 into r bar. Okay, so that is the final formula modified from the above table. So table I will send soon. Okay, so don't worry about. just upper control limit and lower control limit, we will observe only one change, that is a sign in between the average of average and a to r bar, that is a plus and minus. Okay, then you can go for the that once you go see in that table, then we will understand the. Okay, so this is the just a formula, this is just steps from this table where you can easily find out the upper control limit and lower control limit for x chart, x bar chart, r chart. Okay, so next is r chart. So r bar is a solid horizontal line. Please just remember what is mean by r bar. So it is a just horizontal solid line, and upper control line for this R chart, that is a dotted horizontal line, and lower control line for this R chart, that is a subgroup size or 7 or more dotted horizontal line. Okay, so same like X bar chart, X chart. So X bar is a solid horizontal line, and upper control limit, that is a dotted horizontal line. Same lower control limit. म्हणजे मधली असेल ते एकदम सॉलिड असेल आणि त्याच्या वरची आणि खालची अप्पर लोअर ती डॉटेड लाईन असेल. ठीक आहे. So we will see one problem. Okay, so now you can see here control charts problem, that is a following are the inspection results of the magnet 19 observation. तर एक 19 ऑब्झर्वेशन घेतलेत, त्याची तुम्ही रिडिंग बघा. पहिले टेस्ट नंबर आहेत 1 ते 19. नंबर ऑफ द मॅग्नेट इन्स्पेक्टेड, किती इन्स्पेक्टेड केले ते आहेत. नंबर ऑफ डिफेक्टिव्ह मॅग्नेट त्याच्यातून किती सापडलेत, आणि फ्रॅक्शन डिफेक्टिव्ह म्हणजे ते त्या व्हॅल्यूवरून काढले फ्रॅक्शन मध्ये डिफेक्टिव्ह आहेत. ठीक आहे. तर calculate the average fraction defective and 3 sigma control limits, construct the control chart and state whether the process in the statistical control or not. तुम्हाला हे सगळं रिडिंग बघून कॅल्क्युलेशन करून सांगायचं की ही तुमची प्रोसेस विदिन स्टॅटिस्टिकल कंट्रोल आहे, म्हणजे अप्पर लिमिटच्या आत आणि लोअर कंट्रोल लिमिटच्या वरती आहे का नाही हे तुम्हाला सांगायचं. सो वी कॅन स्टार्ट हिअर. ॲव्हरेज सॅम्पल साईज, दॅट इज is equal to total, means total किती आहेत number of inspected 14,091 divided by total process किती आहेत n, capital N 19 सॅम्पल घेतल्यात, तर किती आलं नियर अबाउट 742. ओके, देन ॲव्हरेज फ्रॅक्शन डिफेक्टिव्ह कसे काढायचे. टोटल डिफेक्टिव्ह ऑल सॅम्पल, सगळे डिफेक्टिव्ह किती आहेत सगळ्या सॅम्पल मधून 1030 डिवायडेड बाय टोटल सॅम्पल किती होते 14,091. सो वी विल गेट सम ॲव्हरेज फ्रॅक्शन डिफेक्टिव्ह, दॅट इज 0.0731. Then we can calculate the upper control limit for the P chart. So that is equal to P bar plus, this is the formula for the P chart. Don't just get confused. We have seen some formula for the X bar, okay, R bar. So this is formula for the P chart, and the formula for the upper control limit for P chart, that is equal to P bar plus 3 under root P bar bracket 1 minus P bar divided by N. So here, whatever we have calculated the average fraction defective, that is a P bar value. Okay, so you can just put that P bar value in this formula, and N is nothing but your average sample size, whatever we have calculated at the first of the problem, 742. So in this you can get the upper control limit and lower control limit regarding this P chart. So now you can observe the upper control limit value is 0.10118 and lower control value is a lesser than that upper, that is 0.0444. So now you can see here, you have to draw this chart. So x-axis belongs to the that numbers, inspection number, that 19 test number. Okay, and y-axis that your control defectives. Okay, average fraction defectives. So we have to draw the first solid average line, that is your 0.07. Okay, we have calculated the average fraction defectives, that is a solid line, and upper line and lower line, that is the dashes lines, which is we have calculated already. 0.10118, that is the upper control limit, and lower control limit, that is 0.0444. Okay, once you draw these three lines, then you can go for the drawing this all fraction defective values of the each test. That is the first test 0.066, then 0.106. Okay, once you plot this all the values on this chart, then you will understand which point is going out of the statistical process control. Okay, now you can see here the point number 2 and point number 4, then point number 9. Okay, And again, the last point is out of the lower control limit and upper control limit. So these 4 5 points are not in the statistical process. So you can see here, this is the P chart. So you can see under, you can easily give a conclusion on this chart. So whatever this process is there is not in the statistical control. Why? So because that 3 to 4 points are out of that upper control limit or lower control limit. Okay, try to understand. You have to just find out the value of that particular uh, chart. So here they have used the P chart. So already we have know the value formulas for the X bar chart, R bar chart. So this is problem based on the P chart. So you can just remember this formula, standard formulas. You can just put the values into these formulas. You can draw the chart, and from this chart you can just give a statement whether your process is within statistical control or not. Okay. Next example, you can see again same 16 reading. Okay, sorry, 25 reading is there, aeroplane, and number of missing rivets, that reading is there. So here they have used they have said find C bar chart, C chart, compute the trial control limits and plot the control chart for the C. Specifically, they have asked for the C chart. Okay, and here we have to use the P chart. So again we have to go for the formula for the C chart. Then we have to calculate the average value, that is a 14.04, and again we have to go for the upper limit, lower limit, and formula for that C bar plus 3 under root C, same, just lower limit minus value. So we will get, once you get the upper limit and lower limit for the particular chart, then you can go for the drawing the final chart, and again you can go for the statement. Very easy problem are there. So we have to just remember this basic formula for the X chart, R chart, C chart, P chart, sigma chart. Okay, once you understood the process, then you can go for the final solution. Okay, so like this way there are 4 to 5 problems are there. So from this you have to understand the process, how to find out. First of all, I will just you can just go through the study material, you will get these notes. Once you go through these formulas, once you remember this different charts formula, then it will be easy for you to calculate the different values of the upper control limit and lower control limit for that particular charts. So it will be X bar, it will be C bar, P bar, R bar. Okay, just remember the values. Okay. So we have seen some basic types of the charts, control charts. So we have seen some formulas of the regarding C bar chart, P bar chart, R bar chart, X bar chart. So we have seen 2 to 3 formula problems based on these different charts. So you can go deeply with that study material link. Otherwise, again we will go for the these formulas problems, and we will see discuss again in details. But now I will just give a overview about these problems. Once you complete this chapter, again we will go for the separate for the some different problems. Okay, so you can just go to the study material, you can just see the notes, handwritten notes of this chapter. You will get some idea regarding this different charts, and we can go for the final some more problems, additional problems. Okay, we will see next part. Okay, so our next part is acceptance sampling. Okay, so sampling is one of the type of the just a process. It is the process of evaluating a portion of the product or material in a lot for the purpose of the accepting or rejecting the lot as either confirming or not confirming the quality specification. Means once you got the one lot of the production lot lot means some 50 a product 100 product, and from that 100 product we have to go for the some inspection. So it is not possible to checking each and every product, so we are going to make take some sampling method. So we can take the some different 10 or 20 product from that out of 100, and we can check that product, and based on that product sampling inspection we can decide whether that lot is going to accept or reject. Okay, so for that we are using this acceptance sampling. So in that sampling we have to take different product and Okay, sorry to say, due to some internet problems, we have to stop here. Okay, whatever remaining part we will see in next lecture. So thank you so much. Yeah, sir, you can stop the recording, and now